Assalamualaikum and have a good day. My panel for this project evaluation is DS Aminul Rashid bin Nordin and Encik Syaruddin bin Zakaria. Before I start my presentation, let me introduce myself. My name is Muhammad AMIRUL bin SAZALI and I am currently 4th year student in Bachelor of Electrical Engineering Technology, Industrial Automation and Robotics at UTM. I would like to present my bachelor degree project with the title of Development of Smart Gardening System by using microcontroller. Let's be started. This is a full view poster for my bachelor degree project. I would like to present project overview for introduction. This project is proposed to build an automatic crop management system using ESP32. The idea to develop this prototype was because of the problem faced by many people who love farming and there is no time to take care of the crop regularly. This method is raised because the plant needs careful care to ensure that the plant is always healthy. That is why the idea to develop this project is become. Problem statement. They want to take care of the plant in order to them to grow up. However, they are unable to do so in specific situations. For example, some employees must travel to an outstation for a few days or week, preventing them from caring for the plant and flushing them. So, to ensure the plant is grow healthier without having to give a full attention in terms of the care of the plant, this project is the solution. We go through to the project objective. The first objective is to develop an automated garden prototype by using microcontroller. In this case, we use ESP32 as a controller. Second, to design the monitoring garden system by using IoT. Then we use Blink application. Then third, to analyze the performance of the proposed method of the smart garden system. Project scope. This project is special for the implementation of an automated system for plant or garden in a home area. It uses an ESP32 microcontroller to run this automatic system. In the creation of this project, it will use several sensors that complement the automated system in this project. The sensors that will be used are the soil moisture sensor, temperature sensor, ultrasonic sensor, and LDR sensor. Methodology. The component that have been used is divided into 4 parts. The first one is microcontroller, then power supply, sensor, and load. A solar panel as a main supply in this project. Solar panel that being used is 20 watt, 1.5 ampere, then we have a solar charger controller. Solar charger controller is a voltage and current regulator to keep batteries from overcharging. It regulates the voltage and current coming from the solar panel going to the batteries. For battery, we use 12 volt lead acid 7Ah. Microcontroller that have been used is ESP32 with Wi-Fi. After that, DC to DC step down is to convert voltage from the solar charger controller 12 volt to 5 volt to turn on the ESP32. Next part is sensor. The sensor that we been used is DHT22 to measure the surrounding temperature, the soil moisture sensor to measure the moisture of the soil, then ultrasonic sensor to measure the water level in the water tank. Last part is a sensor LDR to measure the light intensity. For the load, we use 3 different loads to control the system. First one is the water pump to watering the plant, the fan to control the temperature in the greenhouse, and LED grow light to replace the sun at the night to help the plant grow faster. So we will start with the simulation. So firstly we will go to the solar panel. So the solar panel that we use is 20 watt and 1.5 ampere. It will supply the current, the voltage to the solar charger controller that we use, the blue one. So right now the reading is 12.8. It will be charging the battery and give the supply to the overall load. Then right here we have a ultrasonic sensor to measure the water level in the water tank. Next we will go to the LDR sensor. Then we have a DHT22 sensor, temperature sensor right here. Then we have the water nozzle to water in the plant. Then we have a ventilation fan to absorb the heat. So right here we have a soil moisture sensor. The condition is wet right now. So at this time the fan will be turned on because the temperature right now is hot. Okay, I will explain about the Blink application interface that I use. So here we have a 3 gauge that to measure the moisture. Then we have a gauge for the measure the temperature. Then we have a gauge to measure the humidity. So at the left bottom we have the water level, measure the depth of the water. So right now the temperature is 35.1. So the system is running automatically. Then the fan will be turned on because the set point is above. Alright. Then for the soil moisture sensor, the data is 106. So the condition is wet. Then the water pump will be not running. The water pump will be running when the data will achieve 30 and below. So for the LDR sensor at the day, it will be not light up because it will be running when the light intensity is low. So it will turn on at the night. So we'll turn on the push button for the water pump manually. But for the fan, we cannot turn off because the setting right now is set up for the automatic system. The LED we can turn on it manually, even though at the day or the night. Okay. So this is a condition at the night when the LDR sensor detect the low intensity of the light. So the LED will be light up. So that's all. Thank you. Okay, for the result, we have a 2 data analysis. First one is a graph time versus soil moisture sensor. This data analysis is compared between when the plant is in automatic system and manually taken care by human. We can see there is not much change between the 2 data taken and making it successfully. Then we have data for the time versus temperature. It's compared between the automatic system when it's on and off. In this analysis, it is very sensitive because the vegetable type plant cannot survive if the temperature is too high. So the graph shows very little change and it's still above the proper temperature range. So for the ventilation system, need to be upgraded. For the example, adding an additional fan. Okay, for the conclusion from this project, it can be concluded that the use of the greenhouse can be reduced the observation of the soil moisture and ambient temperature manually by 40%. This smart garden can be run smoothly and give an excellent result for the plant grow, but still needs some improvement in this system. Last but not least, I want to thank to my supervisor, Puan ROZILAWATI binti Muhammad Noor, for guiding me through this project, and also my family and friend that's helped me a lot to complete this project until it's successfully. So that's all for me. Thank you so much for watching this. Bye bye.